You ever look at a huge, complex website and just wonder, how on earth is this thing built without collapsing into a total mess of code? Well, the secret, a lot of the time, is this really powerful, elegant blueprint that's been shaping web development for decades. So yeah, let's dive into this foundational pattern, MVC. So here's our game plan. We're going to start with the problem that made MVC necessary in the first place. Then we'll introduce the pattern itself, break down its three main parts, see how they all work together, and then wrap up with why this thing is still so incredibly important today. All right, first things first, why do we even need a special pattern like this? Well, the answer really is all about how much the web has exploded in complexity. Yeah, this image really says it all. I mean, think about it. In the early days, a website might have just been one simple file. But now, we have massive applications where the code for what you see, the business rules, and the data all gets tangled up into what developers call spaghetti code. And when you've got hundreds or even thousands of people working on it, it's not just messy, it's a recipe for disaster. It gets out of control fast. And that's where our hero, MVC, enters the picture. To tame this beast of complexity, developers needed a much smarter way to organize everything. And this brilliant pattern was the answer. So the single most important word here is separation. MVC, which stands for Model View Controller, isn't some piece of software you install. It's a way of thinking. It's an architecture that basically says, hey, let's not mix everything together. Let's divide our app into three distinct jobs. And you know, this idea isn't even new. It was actually invented way back by a guy named Trygve Rinskog to handle complex data and desktop software. But the genius of it is how well it adapted. It became this massive standard for the web and even for the mobile apps we use every single day. This whole separation thing brings some serious advantages. It keeps different parts of the code from messing with each other. It gives us those nice, clean URLs you can actually read. It gives developers total control over the final output, and this is a huge one. It makes testing the application way, way easier. Okay, so let's actually break down those three letters, M, V, and C. Each one has a very specific job to do. We're going to start with the C, the component that's kind of like the director of the whole show, the controller. The controller is basically the traffic cop of the application. When you click a button or load a page, your request goes straight to the controller first. Now, it doesn't touch the data directly and it doesn't draw anything on the screen. It just orchestrates the entire process. So its job is to listen for what you, the user, want to do. Then it turns to the model and tells it what data to update or grab. And finally, it picks the right view to actually show you the results. It's like the ultimate middle manager, just making sure everyone else does their job. This is a perfect example to make it real. When you search for a book on a website, you're not talking to the database. Nope. Your request goes to the controller, which takes your search term and kicks the whole system into motion. Next up, we've got the view. This is simple. It's everything you see and touch. The user interface, the buttons, the forms, the layout. Its only job is presentation. You could say it's the face of the application. The view's job is to take whatever data the controller gives it and just make it look good. It has no idea where that data came from or what it even means. It just knows how to display it, whether that's a list, a table, or a fancy chart. So, back to our bookstore. The view is the actual web page showing the book covers, the prices, and that search bar you type into. It's the storefront that makes all the raw data from the backroom look appealing. And finally, we get to the M, the model. This is the real brains of the operation. The model is responsible for all the data-related heavy lifting. It represents the application's core information and all the rules about how to access and change it. The model is the only part that talks directly to the database, creating, reading, updating, and deleting info. And what's really important is that the model has absolutely no idea how this data is going to be displayed. It only cares about the data itself, its structure, and its integrity. And to finish our bookstore analogy, the model is the inventory system in the back office. It knows everything about every book: the title, the author, the price, how many are in stock. It is the single source of truth for all the application's data. Okay, so we've met all the individual players. Now let's see how they actually dance together when a request comes in. This is where the real magic of MVC becomes super clear. All right, let's walk through this. Step 1, you click a link to see a list of students. That click hits the controller. The controller, acting as the director, turns to the model and says, hey, get me the list of students.
The model then goes to the database, fetches the data, and hands it back to the controller. The controller then takes that raw data, finds the right view, and says, "Here, make this look like a student list." Finally, the view formats it all into a nice HTML page and sends that final result back to your browser. See? A perfect, clean workflow where everyone does their one job.
And this isn't just about being neat and tidy. This is fundamentally good software design. It lets teams divide and conquer problems, it keeps related code bundled together, and it reduces how much different parts of the system depend on each other. That makes the whole thing way easier to change and maintain over time.
So this pattern has been around for a while now. Why are we still talking about it? Well, let's take a look at its impact today and try to get a balanced view, the good and the not so good.
The upsides are huge, especially for big teams. Because everything's separate, your UI designers can work on the view at the exact same time your backend engineers are working on the model. But, it's not a silver bullet. For a really simple one-page website, using a full MVC framework can feel like using a sledgehammer to crack a nut. It can definitely add complexity you just don't need.
And hey, the proof of its success is right here. This isn't just theory. If you've ever used a popular web framework like Ruby on Rails, Django, or Laravel, guess what? You've been using MVC this whole time. They are all built on this solid, time-tested foundation. Which brings us to a really interesting final question. MVC was created to solve the problem of complexity. But as our applications get even more complex, we're talking microservices, real-time data everywhere, is this classic three-part split still the ultimate answer? Or is it just the foundation for whatever comes next? It's definitely something to think about.